I'd like to thank everybody for logging in today. This is the second part of a webinar series of 4 parts where we're looking at how cybersecurity fits into the safety life cycle. Okay. Okay, today's webinar brought to you by Exida, worldwide organization. We offer a number of services ranging from consulting, engineering, certification, training, and the items in green are those aspects of our services that relate to cybersecurity. My name is Hal Thomas. I've been with Exida for about 5 years. Prior to that with Air Products. Started out as a control engineer and spent the last 30 years or so as a process safety engineer. And in the last couple of years there, cybersecurity started to recognize that it really did impact process safety, so stayed with that. The objectives of today's webinar is to essentially provide you an overall awareness of the cybersecurity life cycle. Just as importantly, you want to understand how it integrates with both the process and functional safety life cycles that exist in your companies today. In the last webinar, part 1, we looked at the analysis phase of the life cycle. And today we will be looking at the design and implement phase. On this screen, we showed in the last webinar, we showed how you have the process safety life cycle. In parallel, you got a cybersecurity life cycle, but in reality, you've got a lot of crosstalk between each of the phases so that the end objective is really to have this integrated so that you have a more cost-effective solution. The section highlighted in red, that's where we're going to be focusing on today. This is a little bit more detail of the design portion of the life cycle. Later on, we'll be looking at the implement portion. It goes through performing conceptual design, doing your security level verification, determining whether you've met your tolerable risk criteria of your corporation or not, all your detailed design and procedure development activities, and after that then you go purchase, build, configure. Now that life cycle that we just saw is really coming out of the ISA 84 technical report 84.00.09. It's largely based on that. And with regard to the conceptual design, the inputs are basically coming out of the analysis phase. So now you've completed your cyber risk assessments. That phase culminated with the cybersecurity requirement specification. At this point, you should know generally what equipment that you're looking at and obtain their cybersecurity manuals. Essentially, you need to know just how good the equipment is for the security level that you need to achieve within the zone they're going to be located. You also should know what software platform operating system you're going to be working with, your business area requirements, as well as your process control, the operational requirements for the control system. Coming out of the conceptual design stage, you should have a pretty solid zone and conduit model. Absolutely need to document and show all the remote access points that are going to be there. Also, any boundary device countermeasures that are part that have been highlighted in the cybersecurity requirements spec need to be shown as well. You also have a proposed cybersecurity implementation strategy. Start on your metrics, diagnostics, operational procedures, what test procedures that you're going to need to have in place. This is just an example of why we actually go through and do this. In this incident, a foreign hacker infiltrated a laptop of an employee of a water system, and they were able to use that remote access as an entry point, and from where they installed malware, they also basically were using it to spy, but in the event of some crisis in the world or reason, they could have taken over that particular water treatment plant or done some harm. Next step in the life cycle is to perform a security level verification. If you remember, during the part 1, the risk assessment phase, you're supposed to determine, based upon risk, what security levels your various zones needed to achieve. And that is known as the security level target. And now you got to make sure that the combination of hardware, administrative controls, physical access, countermeasures that you put into place are capable, that's your security level C, security level capability, such that each zone is able to meet the target. When doing this, a lot of people do that qualitatively. We're also trying to develop semi-quantitative methods to do that so that it's more akin to doing a safety integrity level verification. In this case, we'd be doing a security level verification. Here's the 3 security level types. You can have a security level target. That's what comes out of the risk assessment. The security level capability, that is basically, you'll actually have equipment manufacturers report that they have a certain security level capability. What's important there is to know what capability it has relative to specific threat vectors. If the equipment is not up to the security level that you need, or if they have threat vectors that it's just really not possible for them to come up with a security level capability from within the hardware, then this is where it's important for the security manual to let you know what additional countermeasures, alternate means of risk reduction need to be put in place that would be the end user's responsibility to be able to have the security level capability for that zone in total. SLA, that's the actual security level achieved. The only way you know whether you've actually achieved it is essentially based upon proven in use. This is where a number of your metrics are important to make sure that the security that you think you have is actually being achieved through measurement. We've talked about security levels, and the IEC 62443 defines security level 0 through security level 4, with the definition for security level at the top being level corresponding to the required effectiveness of countermeasures and inherent security properties of devices and systems for a zone or conduit based on assessment of risk for the zone or conduit. In the last webinar, we talked about how to go about those risk assessments. Now, when you get into the actual security levels themselves, as the security levels increase in number, security level 1 will be more secure than security level 0, security level 2 more secure, so on and so forth. You will notice that starting with security level 1, the definitions are actually out of ISA TR 84.00.09, which has just gone out for ballot. And the reason for that is the 62443 definitions are still seem to be in somewhat flux, and they are tied to the sophistication of the hacker. In TR 8409, we also started to put in a time period capable of delaying or denying attack for a period of time. So security level 1, it's 4 to 8 hours. When we get to security level 2, we're looking for an increased period of time, but also an order of magnitude in terms of risk reduction over security level 1. Security level 3 would have an additional order of magnitude risk reduction over security level 2, and also an increase in terms of being able to delay or deny an attack, and so on and so forth with security level 4. One of the things in IEC 62443 in their 3-3 document, they define 7 foundational requirements, and within those foundational requirements, they start indicating those items that would pertain to security levels 1, and then what additional things would be needed for security level 2, then 3, then 4. Simply complying with 3-3 would be a qualitative means of ascertaining what security level you are at. One of the problems with 3-3 is that it provides no guidance with regard to physical access security, nor does it provide any guidance with regard to the human resources of personnel management. In order to look at the administrative control piece, there is some guidance in 62443 2-2. However, it's pretty qualitative, and unlike 3-3, it's not really defining things in terms of security levels. So end users are a little bit on their own. That's one reason why looking at the semi-quantitative approach might be provide a little bit more guidance. But certainly 3-3 is a quite useful document in terms of seeing the kinds of things that you would need to have in place to achieve particular security levels. Semi-quantitative approach needs to look at each threat vector individually. You look at that vector and you look at all of the countermeasures that are in place and the inherent security of the design. You're basically looking at the defense in depth that you do or don't have. One mechanism is to use an event tree, another is an attack tree. But when you do this, you need to account for all of the possible vectors, so you end up looking at not just hardware robustness, but also physical access procedures. You look at procedures for the management of personnel, just how effective those are. And for both the qualitative and the semi-quantitative approach, the physical access and the robustness of management of personnel effectiveness, they all need to be commensurate with the security level that you have. When you go down this path, you're actually calculating a value. So you compare that calculated value versus the corporate risk criteria. And if you don't achieve your risk criteria, then you start looking at how can we improve things. At that point, you refine your countermeasures, or you might look at alternate means of risk reduction. Here's an example of an incident that illustrates the importance of both physical access and your personnel management. You had an employee who essentially gained unauthorized access. He had been a former employee, but he gained unauthorized access, installed a piece of software, and then weeks later, he erased a lot of information, and that basically caused the facilities to freeze operations for, I don't know how many days, but a number of days, and they had close to $1 million in losses. After the conceptual design is complete, it should have produced, well, at the end of the conceptual design and the SIL verification, you should have your equipment manufacturer cybersecurity manuals, the software platform operating system. The business area requirements need to be consistent with the cybersecurity requirement specification, and the control system operational requirements needs to be consistent with the cybersecurity requirement specification. Those two sub-bullets illustrate the importance of integrating this work process. You can't develop cybersecurity requirements in a vacuum, and you can't develop business area requirements and operational requirements without consideration of what it's doing to the security. You need an optimized approach. There needs to be some iteration amongst those folks so that you come up with something that's both cost effective but also is going to work for you. So those are the kind of inputs that will come out of both the conceptual design and the security level verification that verified that conceptual design. You go into detailed, you perform your detailed design, and at that point you've got your final zone and conduit models, you've got detailed specifications with which you can purchase equipment. You should have your cybersecurity implementation strategy. I've documented your final metrics and diagnostics, your operating procedures, as well as final inspection and test procedures of your countermeasures. Should also have been developing, as part of those inspection and test procedures, the first place to implement some of those is during the cyber factory acceptance test. The cyber factory acceptance test ideally is done as a portion of the factory acceptance test. Should be developed before the system under consideration arrives at the integrator facility. This is an opportunity to actually perform penetration testing, which is something you don't want to do when your plant is actually operating. You're also going to be developing the cybersecurity site acceptance test plan, after it's been actually installed but prior to startup. That should actually be an evolution of the Cyber Factory Acceptance Test, because now you've got more connectivity, and it's also an opportunity to do potential penetration testing. At the end of detailed design, you want to go through and make sure that does the design work on paper? Make sure that the design is going to do what you intended it to do. Also, want to make sure you didn't make any compromises to compromise the risk reduction requirements. Training should be available and appropriate, with a plan to deliver the training to those who need it. Your network diagrams, complete with the zoning conduit, should be available. You should know how both access is being controlled to both the network and individual devices on the network. And documentation controlled and protected. Once again, everybody's got documentation management systems in place. Cybersecurity needs to be rolled up into that as well. At the end of the design phase, the detailed design phase, just like in the functional safety world, where they have functional safety assessments, as part of those or as separate activities, you should be doing cybersecurity assessments. And at this stage, this is stage 2. It's right at the completion of detailed design, but you want to do this before the integrator begins their work in their shop. Should be done independently, needs to be done by competent personnel, and properly documented and communicated. The whole key here is you do not want surprises. The real reason for doing this is to manage cost. You do not want future rework. Worst thing to do is to let the contract to the fabricator, and a month after they've started, you go through and you do this security assessment, you find a lot of problems, and now you're into scope changes with the fabricator, and that adds cost to your project. So that's what you're really trying to avoid. Now you got the fabricator going into system integration. Idea is to build a system that meets your requirements that you've specified. You also want to make sure that the system is not compromised during this phase of the work, which means when you select integrators, you want to actually take a look at how well do they protect themselves from a cybersecurity perspective. What kind of competence do they demonstrate in this area? You want fabricators who have a level of security that is commensurate with the security level that your equipment and systems are intended to meet. And here we've got a list of number of qualification and competency review items that you can take a look at. You want to see if they've trained their personnel. You want to see if they've got proper handling of cyber safeguarded equipment. Do they understand the applicable industry standards? Do they also understand some of the enterprise stewardship standards in the area of cybersecurity? One example is the NIST framework, that you can actually use the NIST framework to audit the fabricator to see how well they stack up. Has the fabricator actually integrated their company policies and procedures to incorporate cybersecurity within their projects? What kind of procedures do they have for recovery so that you can get the equipment back to its initial state? What kind of use of logs and sampling do they do, and do they have past examples of enforcement, and have they demonstrated improvement by use of metrics? So now we'll look at the implementation phase, starting with the cybersecurity FAT, then we move through installation and commissioning, cyber site acceptance test, initial validation of countermeasures, and then finally the pre-startup safety review. And that would be the end of this phase. Timing of the cybersecurity FAT. Thing that makes the most sense is to actually make it part of the traditional factory acceptance test. Once again, the intention is to make sure that those countermeasures that can be inspected and tested, that they've been properly set up, configured. Just as with any other FAT, any items found to be deficient, they need to be fixed. The inputs to an FAT, pretty much the same as the regular FAT. You need your inspection and test procedures. You need your detailed design documents to check against. And in the safety world, you'd have a safety requirements spec that you want to check things against. Here, you should have a cybersecurity requirements spec to be able to check against. Method, you'll actually use the actual component versions when you test them. You want to perform as realistic a test as possible with the simulations. This is an opportunity, as I indicated before, to do penetration testing. There's a new term, technical currency. Unfortunately, although change is good, in the area of cybersecurity, change happens much more quickly than what a lot of us are traditionally used to, particularly in the area of people doing the attacking. And so if there's new zero-day events and you've had remedies to counteract those things, you basically want to play catch-up if that's necessary to actually get up to the technical currency of the day, as opposed to what may have been true 6 months prior. Once again, resolve any issues prior to commissioning and startup. At the end, you'll have a signed-off document of the procedure with pass or fail, and any notes, observations that need to be sent forward as the equipment gets shipped to the site that needs to be dealt with. After that, equipment arrives on site, it's installed, it's commissioned. As part of commissioning, you'll confirm that it's configured and installed per the specs. You want to make sure that barrier devices only allow the traffic that is needed and that it blocks any unwanted traffic. That should all be well documented as what's appropriate. And if it's not appropriate, then it's unwanted. Also, if you find unwanted traffic, then logs should be generated and addressed and dealt with. At the end of installation commissioning, you're essentially making it ready for the cyber site acceptance test. Here, when you get into this, you should have available to you your system inventory, all your inspection and test procedures and countermeasures that are supposed to be in place, all your detailed design documentation, as well as the cybersecurity requirement spec. To accomplish the test, You'll basically inspect and test as appropriate each of the countermeasures, make sure that the system is up to the recommended level of technology currency. Any changes that have been made at any time, you want to make sure that all of those changes have been adequately reviewed and analyzed. These could be firmware, software updates, network, engineering integration, connectivity patches, any of this stuff. If changes have occurred, you want to make sure that the change has not compromised the system at the very least, and in some cases hopefully made things better. But unless you look at it and analyze it, you don't know. Any proposed or discovered modifications that might impact the security level, they've all got to be looked at before implementation, and at least preferably you'll do that upon discovery to be a little bit more efficient. Once again, now that you've got your more complete communication traffic, you'll compare again the required versus the unwanted network traffic. And lastly, resolve any issues prior to the formal initial validation. Coming out of the cyber site acceptance test, you may find that through changes, you want to make sure that your system inventory is fully up to date, and all of your documentation should reflect the as-built that is commensurate with the security level that you want to achieve. Initial validation is like the initial proof test of a safety instrumented system, only now we're looking at cybersecurity countermeasures. You've got to make sure that they're tested and practiced with the plant support personnel, because when we look at cybersecurity countermeasures, we don't generally have things that, in a number of cases, we have things that slow an attack down that needs to be responded to. In some cases, it will prevent certain traffic, but there you need to make sure that it's configured properly and working properly. You want to make sure that the access control hierarchy is set up and finalized. All the support work processes and procedures have been finalized and practiced and tested. Also, all your metrics that you're going to have in place, that those systems are actually collecting information properly, reviewed, so that they're actually functioning in a production environment. Any deviations you discuss, they all need to be resolved, and they all need to follow your change management practices. All of our companies today should have management of change policies and practices. May need to tweak those to make sure that cybersecurity is managed in the process plant world with a similar level of rigor as your safety instrumented systems. At the end, you'll do a cybersecurity assessment 3 at the end of design and implement. This should be conducted as part of the pre-startup safety review. You can treat it separately, but I personally believe that the Cybersecurity Assessment 3 is simply a contribution to the PSSR. As before, with all of these cybersecurity assessments, the work should be checked. It should be an independent check of the work. You need competent personnel, and you need the work documented and communicated. And here, once again, the idea is you don't want any surprises once you go into operation, and you do that by ensuring that the plant is both secure and safe to begin operation. So in summary, we looked at the life cycle portion of design and implementation, starting with conceptual design, moving through security level verification, which could be qualitative or semi-quantitative. We also looked at the detailed design and procedure development portion of the life cycle, then moved into system integration. After systems integrated at the shop, you've got your cybersecurity factory acceptance test, equipment shipped to the site where it's installed and commissioned, after which it can go through a cybersecurity site acceptance test in preparation for the formal initial validation. And prior to startup, you need the cybersecurity contribution to the pre-startup safety review. And that brings us to the end of this webinar. And let's see if we've got any questions here. Let's see. Okay. When is the official exida cybersecurity guidebook release date? Exida does not have a cybersecurity guidebook in progress, but what we are doing is we are working with, as a matter of fact, I chair ISA Technical Report 84.00.09. That technical report, we do try to work with the S99 committee so that we can play nice with the IEC 62443 series of standards, which are some of which are published, some of which are being developed, some of which are being reviewed and updated. As I said, about a week ago, we went out for ballot on that technical report. There is an S84 meeting in the second week of October, and my team hopes to begin, well, basically we'll see if it's approved or not approved. Either way, I suspect we're going to get comments that we're going to have to address and resolve. And either way, I would expect to hopefully get all those resolved by the end of the year. So assuming that the technical report gets approved, I would anticipate that sometime in the first quarter of 2017, that document would then become available. Okay, do we have any other questions? Oops. Yeah, let's see. Okay, do you see a trend where client operating companies for the likes of Chevron, Exxon, etc., have started requiring cybersecurity risk assessment documents as deliverables on the projects? Yes, I do see that. To date, there's been a number of major corporations that have actually started engaging in cybersecurity risk assessments. Typically, what I've seen so far is that these are done as part of revalidations, or they will do a vulnerability assessment to take a snapshot of just where they feel they stand against recognized and generally accepted good engineering practice, get their documentation in line, and then actually do a cybersecurity risk assessment to see if they're satisfying corporate risk criteria. I certainly see the trend whereby that will begin to move into the project phase. Later on, after we get through with the series on the life cycle, we will have 2 additional webinars, one on the high-level risk assessment and one on the detailed level risk assessment to get into the details of those. Okay. Let's get the next question. Let's see. One just came up as per, that doesn't make sense, as per the 62443 standard. That's not really a question. And when is the official? Okay. Next question is, do many operators have any risk criteria? Yes. Most all the majors have risk criteria. The risk criteria that we would use for cybersecurity, certainly for safety, where you're doing traditional HAZOPs and possibly doing LOPAs, and you're looking at process safety, the risk criteria would be exactly the same for cybersecurity. In theory, when you look at business interruption and business loss, the criteria, the risk criteria would be the same. There also. Sometimes it's worthwhile to look at the business loss category just to make sure that when the cyber risk assessment team gets together, that particular events can consistently be assigned to a particular category. What you don't want is for every cybersecurity event to translate into loss of the corporation, the most severe risk, because that's not really reality. So you need to make sure that you can realistically say differentiate between how much is an hour of downtime going to cost me, how much is a day of downtime going to cost me, how much is a week of downtime going to cost me, how much is a month of downtime going to cost me, those kinds of things. And then when you get into the risk assessment, you can do a much better job of coming up with the right level of discrimination. Okay, what is a difference in testing between initial validation and pre-startup safety? You're not really testing in the pre-startup safety review. The pre-startup safety review is a fairly standard activity in all of the process plant world. It started out in process safety management. In the area of functional safety, they call it the Functional Safety Assessment 3, and now in the cyber world, we're calling it the Cybersecurity assessment 3, but it's really all part of that pre-startup safety review. And what that review is doing, it's really taking a group of independent folks and doing a paperwork exercise and walking around the plant, making sure that things match up to what they're supposed to match up. You want to, it's really a quality assurance checkpoint. It's not a test. So what you're doing is you've had your initial validation test. The PSSR would want to take a look at the documentation of that initial validation test to make sure, first, was the test actually done? Okay, and secondly, what was it done to the degree of rigor that it was supposed to be done? If not, then you have findings. How can you achieve a cybersecurity risk assessment on a third-party package which hangs on to the main automation control network, especially when the main automation contractor takes no responsibility for third-party networks? The end user is the one who owns it all, and that's the entity who's going to have to perform the risk assessment. You can have these other folks, the main automation contractor would participate. You might have the third-party contractor participate, but the final arbiter is going to be the end user. And at the end of the day, whether these other folks, they're not going to take responsibility beyond what they have control over, but you've got control over everything. And if you need something from them so that you can make the determination that everything can play nice together, then you're going to have to do that. Okay, next question. Do many oops, already answered that question about the risk criteria. And I think that's the end of the questions. Let me just double check here. Yeah, I don't see any further questions. I'd like to thank everybody for tuning in today. And in about a month or so, we'll be having the webinar for part 3. So with that, we're going to sign off. Thank you again.